Okay, what about interrupts? That's the final, thing that we want to deal with here. So the interrupts, well, actually this seems like it might work pretty well. Suppose we want to have an interrupt happen between the add and the sub instruction. We want to say, okay, we want to do the add, but we want to start executing someplace down here in the interrupt handler. So after the add, we want the next instruction to be executed to be the first instruction of the interrupt handler, which is the OR instruction. We don't want to do the sub. Okay, well, it seems like maybe we could just use our rewriting mechanism perhaps to do something interesting. Suppose we decide that we can figure out in the IF stage that we want to take an interrupt, right? And so what we do is instead of fetching the sub instruction, when the so-called interrupt, we recognize the interrupt in the IF stage, we could then, as the add now goes through the pipeline, we at this cycle say, psst, IF stage, instead of fetching sub, go off and fetch, the first, this magic from whatever the magic low core, 8004, 8008, whatever the magic, places are, the interrupt handlers live, go fetch the instructions there. So it seems like this is a good plan. We have a way of, without wasting any cycles, no instructions to throw away. If we make our decision in the IF stage, then there's no unfortunate instruction that got fetched into the pipeline that we don't want to execute. Right, so this seems like a good plan. It has, unfortunately, more flies in the ointment. Someday someone's going to come up with this big jar of goopy stuff with flies in it and say, here you go, Chris. 004 in a nutshell. Flies in the ointment. Okay. Okay, so the problem is that in addition to switching the instruction stream from the add down here to the interrupt handler, we have one more mission, which is we have to remember where to resume execution of the program we interrupted. And the way we remember that is we need to basically write the PC+4 value, in other words, in this case, the address of the sub instruction, into the XP register. If we look down here in the write back stage, you can sort of see that our dance card is full. There's really no cycle in which we can say, okay, by the way, register file, could you please write this magic PC+4 into the register file? We were very clever here at sort of keeping things going, executing only the instructions we want, but we were too clever and we didn't leave ourselves time to write the PC+4 value. So instead, we're going to take the instruction we want to interrupt, and instead of executing it, we're going to rewrite it as one of those magic B&E, please capture PC+4 into the XP register instructions. So that means that we actually, the value that we're saving in the PC+4 thing represents, we haven't executed the instruction before where that XP register is pointing. So we have to be a little bit more clever. Okay, but do you see sort of how so what is it we're doing with instructions? Occasionally we rewrite them with no ops when we don't want to execute them. Okay, when we're throwing them away, we're annulling them. Right? And when do we see ourselves rewriting things with no ops? In the case of branch delay slot instructions, when we took the branch, we don't want to execute the instruction that was in the IF stage. And also when we're flushing the pipeline, we detect some fault in some pipeline stage, and all the earlier stages, all the instructions in the earlier stages, which come after the faulting instruction, actually have to be rewritten as no ops so they don't actually get executed. Okay, the other thing that we rewrite is this magic B&E, please store PC+4 into the XP register instruction. And we use that whenever we're going to stop execution. So in this case, we did that when we detected instructions we couldn't execute. ILOPS in the RF stage, arithmetic faults in the ALU stage, memory faults in the memory stage, so forth and so on. Okay, so we have this rewrite, and that gets the job done. Okay, so all that's good. We have a way of basically rewriting this add as a B&E, which means the add wasn't executed. So at the end of the interrupt handler, we have to remember the XP register is now pointing to the instruction after the add. We have to back it up, so we're now, the XP register is pointing at the add instruction, and then we do this jump. So we're making a small correction. We know what the hardware has done. And so we're making a small correction to the XP register before we use it as the place to resume execution of the user program. And all that's taking into account which instructions we have executed and which we haven't.